Our video today is product of squares. We're going to be working with non-perfect roots, and what we're going to be doing is a little bit of difference of simplifying. There's a lot of stuff in this video, so you may want to be rewinding it, pausing it, going back and looking at it more than once for this section, because there's two major concepts here. So the first one is product of squares. What we're going to look for is the factors of the number under the square root symbol, because we are not working with perfect squares. One of the factor sets contains a perfect square. This comes from your chart. So we're going to find a factor that is going to be a perfect square that we're going to end up pulling out. We're going to take the root of the perfect square and bring the rest along. So these are kind of the steps that we're using. We'll start small and get a little bit bigger. So our first example is the square root of 20. What we're going to do is we're going to look for factors of 20. So I've already kind of made the table up here. 2 times 10, 4 times 5, and if there's more, continue. But the moment that you find one of the factors as being a perfect square, you can stop, and that's what you're going to do to break up the problem. So instead of writing the square root of 20, we're now going to write it as the square root of 4 times 5. If 4 times 5, we get 20, so that changes it. Well, here's our perfect square. This one is not the perfect square. So what we're going to do is we're going to take out the perfect square here, and we're going to put it in front of the radical sign. And we're going to bring along the imperfect or the non-perfect square into our answer. So the factoring of 20, the square root of 20, ends up to be 2 times the square root of 5. Again, the 2 is the root of square root of 4, and the square root of 5 is just the non-perfect that we're going to bring along because we can't factor it out anymore. So a couple more examples. We have the square root of 60. So here are my factors that go into 60. 2 times 30, 3 times 20, 4 times 15, 5 times 12. And again, I've identified that this is the one that has the perfect square. So we're going to break it up into 4 times 15, 4 being the perfect square, so we're going to pull that one out and actually take the square root of 4, gives us 2. Whatever's left is going to be brought into our answer. So our answer for the square root of 60 is 2 to the square root of 15. For 600, the square root of it, here's our factors again, 2 times 300, 3 times 200, 6 times 100, 10 times 60. Again, this one has the perfect square in it. So we're going to rewrite it as the square root of 100 times 6, or 6 times 100, doesn't matter. We're going to pull the perfect square out, which is 10 of 100, and then our 6 just comes along because we can't factor it out. It doesn't have a perfect square. 135, the square root, 3 and 45, 5 and 25. So again, our perfect square factor is 25 times 5. So we're going to rewrite that here, pull our perfect square out, leave our imperfect or non-perfect square into our answer, so we end up with 5 times square root of 5. Our last example in this one is the square root of 250. So we're going to break it into 2, 125, 5 and 50, 10 and 25. And again, here's our one that has a perfect square in it. So we're going to break it down and say 10 times 25. 25 is our perfect square. We're going to pull that out. Our 10 is going to stay under the radical sign, so our answer comes out to be 5 times the square root of 10. So remember, we're looking for a factor set that has a perfect square in it. Take that out and bring the rest in. So again, if you look through the examples, know your factoring. This should be not too difficult of a section. Our last section in this one is equations with roots and exponents. One of the terms especially that we're going to start getting into is equations. So this is kind of the basic introduction to that. We're going to solve for a variable, which is our letter, and it has an equal sign, and that's the reason why we call it an equation. We always want to do the opposite operation to whatever the number is attached to the letter, and we'll go through that as we go through the examples. So if I take a small short example, x plus 4 equals 9. Our variable is x plus 4, or the positive 4. This is what's attached to the variable. And then our equal sign in 9. So we've got to make sure we balance our equations out. So we do the opposite operation to get rid of what's attached and do it to both sides. So in our example for solving it, we would have x plus 4 equals 9. The opposite of a positive is a negative. We take the opposite of that number attached to it, and we do it to both sides, and that gives us our answer of 5. And yes, some of you can look at it and go, well, I already know the answer. Don't care, got to have the word. So opposites in both sides. So some of the other types that you're going to run into on this is x minus 5 equals 4. Again, negative 5 is attached to the x, so we get rid of it by a positive 5 to both sides, and we combine our numbers on the right-hand side. We have 2x equals 4. 2x is multiplying, so we do the opposite of the number attached, so divided by 2. And again, we do it to both sides, and we get x equals 4. Our last example in the basic one is x divided by 3 equals 9. Well, the opposite of division is multiplication. So we're going to multiply this, and being it's in the denominator spot, we're going to multiply it, and you can think of it as multiplying by the reciprocal. We have 3 over 1. These two will reduce out and leave us with x. And then we just have 9 times 3 over on this side because we don't have a fraction, gives us 27. So again, a basic view of equations as we go through it, but we're not going to get too tough yet. We'll get to that later. So if we go through this, remember, do the opposite operation to both sides. So positive, negative, negative, positive, multiplying, dividing, multiplying, or dividing, multiplying, multiplying, dividing, and then we're going to throw in our square roots and our squares. So x squared, the opposite of that is taking the square root of it. When we do that, these two reduce themselves out. And you can say they cancel each other out, but we'll say reduce. Same thing here, if I have the square root, I'm going to do the opposite, and I'm going to square it. And again, those will make each other kind of disappear in the problem. They reduce down to the value that it is. So our examples here, x squared equals 9. We have this. We want to take and get rid of the square on this one, so we do the opposite, which would be the square root. So these two would reduce themselves out, leave us with x. Well, we have to do the same thing to both sides, so the square root of 3 is just 9, or square root of 9 is just 3. But there's a twist to these. So be careful with this, because if I check this and I throw back what I know about now into my answer, I can actually have two answers because a negative or a 3 squared is 9, but if I have a negative base to an even power, that's still positive. So I can get a positive 9 even though I have a negative 3, because again, I'm using parentheses, which groups it and gives us a negative base to an even power. So again, you can have two answers, and your two answers would be negative 3, positive 3, and you can just put 1. Sometimes I'll let you know on that. Our second example, x squared equals 4. So again, we're going to do the opposite operation. These will reduce themselves out to give us x. But again, we have the square root of 4, which is 2. But again, I can take, and if I use the parentheses correctly, and I square a negative 2, I can also get 4. So this is the purpose and reason why you can get two answers in your problem. Next one is, we have a little bit different. So we have actually two steps in here. X squared minus 36 equals 0. We have a positive 36. That's the opposite of the 36. We do it to both sides, so 36 plus 0. So we end up with x squared equals 36. So when we do these reduce down to 0, which is what we want. That leaves us with x squared. We take the square root of our x squared, and we do that to both sides. And again, we can get two answers of a positive 6 and negative 6. So some keys to remember: do the opposite operation to both sides, and you can have two answers. Now, the biggest thing that's going to happen here is a variety. So if you know the basics, it'll help you through this, and if you keep everything straight and neat. So again, our example is p squared equals 79. We're going to take the square root of p squared. Again, these will reduce, leaving us with p. And we have the square root of 79. Now, this is not a perfect square, so we can leave it as the square root of 79, but we also have a positive and a negative one. Or you can write it as a positive over a negative and kind of simplify your answer in there. If I check it, again, when I square this, I'm going to put in parentheses. The square cancels or reduces the square root, which gives me 79, 79. And it does the same thing here. If I have a negative base to an even power, I get a positive. Power reduces with the square root, gives me 79. So again, you've got to make sure you understand the basics, so please ask questions. Here we've got a two-step. where we have to take, and 7x squared is 700. We have 7 divided by 7 because it's multiplied. We do it to both sides. We get x squared. We take 700 divided by 7 gets us 100. So again, we're down to taking the square root of x, which also means we take the square root of 100, and we get our two answers again, x equals -10 and +10. Again, you can check it through here. As I work through my work, you can see the fact that it works out with both positive and negatives. 8x squared equals 200. Again, we have to divide first. These reduce down to 1, which is just 1x squared. 200 divided by 8 gives me 25. So again, I'm going to take the square root of this to get rid of the 2, the power of 2. And the square root of 25 can be also positive, and it can also be negative. Our last example is x squared plus 49 equals 0. We would have to get rid of the 49 first by taking it by the opposite. And again, we show that it reduces out. We come down here, it gets us a -49. We have x squared on this side. We're going to take the square root of that to reduce out the square. But we have a negative inside the radical, and it's a square, or square root. So this answer comes out to be not a real number because, again, you don't have the same number to get to a -49 when you square it. So, keys to your success in this section. Recognize the operation in the equation. Find what is attached to the letter. Do the opposite operation to both sides by what is attached to the variable. And again, the variable is the letter. Solve. Our goal is to always get our variable, the letter, by itself. We don't want any signs, we don't want any powers, we just want it the letter. Check it. This is a way that you can always get 100% on these problems if you just take the time to check it. But use parentheses. You can have two answers, but may only give one if I give you a multiple choice problem. 6, show all steps. Down the paper, work your way in this direction, not left to right. And the biggest thing is be neat. So take your time on this one, work through it, ask your questions.